Well, good evening, dear students. In last class, we discussed about the principle of gravimetric analysis. What is meant by gravimetric analysis? The unit name is gravimetric analysis. Unit second, gravimetric analysis. Here, in this, the what is meant by gravimetric analysis and qualitative, quantitative, and some methods of one is some weight method. There are two types of weight method. One is a sample weight method, the original sample weight method, and the final weight of free precipitate, which contains its sample constituent being state. These two types of weight method, and another you have in gravimetric analysis you apply the precipitation method, voltization method, electrogravimetric method, electroanalytical method. You have some methods and advantages of gravimetric method. This concept we discussed in last class. In today's class, I am going to discuss about the steps or techniques involved in gravimetric analysis. You know the 8 steps are involved in gravimetric analysis. First one is a precipitation method. First one is precipitation method. This is a very important in precipitation method. You are using this method only in the gravimetric analysis. In that, you found the co-precipitation, post-precipitation, digestion or azine or filtration of precipitate and washing of precipitate and ignition of the precipitate and weighing of the precipitate. These are the 7 steps involved in gravimetric analysis. First one, the precipitation method. In precipitation method, this is a very important, the most important method, and in gravimetric analysis, the constituents being determined. Here, the precipitated from solution and the precipitate is separated and weighed. Any of the solution you taken and you added the suitable reagent and precipitate is formed and the precipitate and weighed. Next, the principle of precipitation. For this principle of precipitation method, here the using the precipitation method, you are taking any of the example. Here, the precipitation method is a suitable quantity of solvent is taken. Here, the or sample here, sorry, a suitable quantity of any of the sample you taken is accurately weighed and dissolved in the approximate solvent to get a solution. Here you taken any of these sample and it is dissolved in solvent and it get a solution. Then it is treated with direction is a suitable precipitation reagent. Under here you added the suitable precipitation reagent and component is the concentration of compound is formed and then the precipitate is formed here. This is a precipitation method here. What is by here? What is the principle here in precipitation method? Using precipitation method, the species or element here, if any of the species, I told the sample. Sample means any of the species, any of the species or element. You taken any of the species or element to be estimated is selected. Because of this, if I estimated here, it is a quantitative analysis. You in precipitation method, this is a quantitative analysis, and to be estimated is selectively converted into an insoluble precipitate. If any of the species is taken and dissolving any of the solvent and it is converted into precipitate. This is converted into precipitate. Here you are converting into precipitate. You are any of the forming precipitate reagent. You are insoluble precipitate. Here this is a or insoluble precipitate. Here, this is an insoluble precipitate by the addition of a suitable precipitating agent. Here, you are adding addition of suitable precipitating agent. This addition of suitable precipitating agent, then it converted into insoluble precipitate or a precipitate. Here, the formation of precipitate, and the precipitate either itself should have a known composition. You know the precipitate composition itself. You have the known composition, or it should be convertible. It is usually by heat. Here it should be converted and dissolved into the some other compound which has a known composition, knowing the weight and composition of the precipitate. Afterwards, you know here the weight and composition of the precipitate or the component into which it has been converted. The weight of the species under it easily calculated. You know the composition and weight. This calculation is easily calculated. Weight of the precipitate here. Principle. In principle, you explain the principle is you taken any of the sample like the any of the species or element, and element is or this species or this sample is converted into precipitate or insoluble precipitate by adding or addition of suitable precipitating agent. When you are added this suitable precipitating agent, it gets converted into a precipitate or insoluble precipitate, and you know the composition of the precipitate. Afterwards, you dry and weigh this precipitate and calculate the precipitation quantity. This is a principle. And next, I take some example for this precipitation method. For example, First one, first example. In the determination of silver, a solution of the substance is treated with an excess of sodium chloride. Here, the determination of silver. You are determining the determination of silver. You are waiting or determination of silver or weighing the silver here. And determination of silver, a solution of the substance is treated with. Here, this solution of substance is treated with sodium chloride, NaCl. Here this is treated with sodium chloride or potassium chloride. Here we are treating sodium or potassium chloride. In you taken a silver solution, substance is treated. You are determining the silver. This silver solution is treated solution of substance is this solution of substance is treated with sodium chloride or potassium chloride. Sodium chloride, potassium chloride solution. We are taking this solution and the precipitate is filtered off. Here the formation of precipitate is formed and the precipitate is filtered off and well washed to remove soluble salts. Here the soluble salts are removed and it is washed 10 to 20 times or 15 times. Is remove the soluble salts and dried at 130 to 150 degrees Celsius. The precipitate is dried at the temperature is 130 to 150 degrees Celsius and wait when it heated 130 to 150 degrees Celsius your precipitate is dried and your precipitate is weighed as silver chloride. Here you are treating this one silver. This your determination of silver solution of substance you are treating is treated with sodium chloride or potassium chloride. Finally, your precipitate is that is the weight as the silver chloride AgCl. You are writing AgCl. This one silver chloride is an example for precipitate of converting to the product. Here the formation of converting to the product, this is a first example, only silver is taken as an example. The second example for this precipitation, the constituents being determined in way in a form which is the precipitated. For example here precipitation method, for example second one, magnesium is precipitated as ammonium magnesium phosphate. Here second example, magnesium is precipitated magnesium phosphate. Here precipitated ammonium magnesium phosphate. Magnesium phosphate. This one, the magnesium is precipitated with the ammonium magnesium phosphate, that is a Mg ammonium magnesium phosphate, MgNH4. This is the ammonium and phosphate, PO4. This is a formula for ammonium magnesium phosphate and it is precipitated. This magnesium is precipitated ammonium magnesium phosphate at 6H2. This is the hydrous 6H2. But here this is a way, and after the ignition, the pyrophosphate, that is magnesium pyrophosphate is formed, that is Mg2P2O7. Mg magnesium pyrophosphate is formed, Mg2P2. This is a magnesium, that is a pyrophosphate. This is a way of pyrophosphate. You are weighing and tried this one. The water molecule is removed here. The formation is finally get the precipitate or residue. This one, the pyrophosphate is, you get the pyrophosphate as an example. This is the second example in precipitation method. Next, third example. The calcium is precipitated from natural water. Third example. Calcium is precipitated from natural water using oxalic acid. Here, this is using, that is a precipitated from natural water using oxalic acid, that is H2C2O4. Oxalic acid, molecular formula H2C2O4. Oxalic acid as calcium oxalate is formed, CaC2O4. The formation is calcium oxalate, CaC2O4. This name is calcium oxalate. Calcium oxalate. And here, but after the filtration and ignition, it is made as the calcium oxide. After ignition, it is made as called calcium oxide. Okay, this is a procedure for in precipitation method. Write this one is dissolved in the natural water, that is a ammonia. Here 2NH3. I will write here the reaction, only this I will give you this reaction. Calcium is treated in natural water using oxalic acid. 2NH3 plus oxalic acid H2C2O4. Here the formation is ammonium radical and another oxalate radical. Here 2NH4 plus C2O4 minus. And next, this converted the ions to form a calcium oxalate. Is a sodium. This is a calcium plus 2 aqueous plus another the C2O4. This one Ca plus 2 and this one C2O4 minus 2. This is formation is this one CaC2O4. This is calcium oxalate. Finally, afterwards, this one you are cooling, dried, ignited, filtered, dried and ignited, and afterwards you are weighing the weight of calcium oxide. Here this calcium CaC2O4 is a solid. After ignition, heating takes place. The formation is calcium oxide plus CO plus CO. These two are the gases of formed here. The calcium oxide is solved. This is a way of weighing the your precipitate. This is a third example. Calcium oxide is weighed in this example. Okay, next, the optimum conditions for precipitation or conditions of precipitation. Optimum, this is a very important, this is a 5 mark question. Write the conditions of precipitation or write the or explain or write the optimum conditions for precipitation. Optimum conditions for precipitation. This is a 5 mark question. Conditions for precipitation. Here, some several conditions are there here. The general rules may be adopted for the precipitation. Here, the general rule. Only general rules here. There are number of general rules are there in optimum conditions for the precipitation. First one, precipitation should be carried out in dilute solution. Here, first point, precipitation, that is a repeated. Precipitation should be carried out in dilute solution. Should be carried out in dilute solution. Carried out in dilute solution, as this minimizes errors due to co-precipitation and as this minimizes errors minimizes errors due to co-precipitation. This is the first point. The precipitation should be carried out in dilute solution. It carried out in a dilute solution. It easily formed the precipitation here, or it is the solution, as this minimizes the errors due to the co-precipitation. Afterwards, I tell you this one, the what is meant by co-precipitation and post-precipitation. Second point, second one, the reagent should be mixed very gently. Here, or very gently or very slowly. The reagent should be mixed slowly with constant stirring. Here, second point, the reagent should mix. The reagent should be mixed very gently or slowly with constant stirring. With constant constant stirring. With constant stirring, as it helps the growth of large regular crystals. As it helps the forms of, or it helps the form growth of large regular crystals. Here you are adding slowly, it is a constant stirring. You are adding the precipitating reagent slowly, drop by drop, and it is a stirring, constant stirring, and it helps to the growth of the large regular crystals. It is helping for the large formation of growth of large regular crystals. And third point, this is the second point. Third one, it ensures the complete precipitation. Slightly excess of the reagent should be added. And here the mixing is, it is you mix the chemicals in a order wise. When you are not using order wise chemicals, you are not adding the order wise chemicals. Here it not form the larger regular crystals here. The third one, to ensure complete, to ensure complete complete precipitation, complete precipitation, slight excess of the reagent should be added. Here, when extra the precipitation is forming, here irregular growth of crystals are formed. You are complete the precipitation. After completion of the precipitation, you had some excess of the precipitating reagent that it forms into the subsequent of operation should be carried out here. The subsequent operation should be carried out when the precipitate is formed. Next, you repeat the same procedure here. This is the third point. Next, fourth one, the same order of mixing. Fourth one, the same, and I told this one, the same order of mixing. The same order of mixing. Mixing of reagents. Same order of mixing of reagent should be maintained in replicate data. Replicate means copy. Replicate determination. Replicate determination. Here, the fourth point is the same order of mixing of reagent should be maintained in replicates determinations. Replicates means copy. Here, you are taking repeatedly reagents here. This is the fourth point. Next, fifth one. Fifth point. Precipitation should be carried out in hot conditions or solutions because here the precipitation should be carried out in hot conditions or solutions because the precipitate is stable at high temperature because the precipitate is stable in high temperature. In laboratory, you are doing this gravimetric analysis. You heated your solution or sample. After heating, you add a precipitating reagent. Afterwards, you are adding the precipitation reagent. It form a precipitation crystals because of the precipitate is stable in the high temperature. This is the fifth point. Next, sixth one. Remember, these optimum conditions of precipitation is very important for practical purpose also. In at high temperature solubility increases. In high temperature solubility increases. Here, the high temperature solubility increases and coagulation is persists and solution formation decreases. And here, solubility is increases. We are adding in hot solution or hot conditions. The solubility is increases and coagulation is persists. And solution formation decreases. This is the third reason. At high temperature. And third one is the velocity of crystallization. Crystallization is increases. Here, the velocity of crystallization is increases. Here, precipitation should be carried out in hot condition when your solution is hot in room temperature. In hot condition, you add the precipitating reagent. The precipitate is stable in high temperature because here the solubility is increases and coagulation is persist and solution formation is decreases and the velocity of crystallization is increased. This is the fifth point. Next, sixth one. The crystalline precipitate should be degraded and for longer duration or overnight here. Right here, this is point. Sixth one. After the formation of precipitates. Fifth point is the formation of precipitate. Here the sixth point is after formation of precipitation, and it is digest here. It digests for longer duration. For longer duration or in overnight, one night. It easily settle down here. The precipitate is settle down stream. Stream bar. Stream bar. In order to avoid here, because of you are in order to avoid the problem of co-precipitation and use more readily filterable precipitate. This is the sixth point. Here you are digest for longer duration or overnight steam bar. You are digested in a steam bar because of you minimize or it avoid the formation of co-precipitate. This is the sixth point. Next, seventh one. The precipitation should be washed with suitable dilute solution. Here, the formed precipitate. In fifth point, precipitate is formed. Afterwards, it digests. It digestion in a longer duration or overnight. After you keep the overnight, after the precipitation should be washed with suitable dilute solution. Suitable dilute solution. Or you can wash with water. Suitable dilute solution of an electrolyte. The washing of precipitate with water may cause peptization here, or that is a hydrolysis. It causes hydrolysis. You use hot water or you use the suitable wash. The suitable should be washed. Here, the precipitation should be washed with suitable dilute solution. Okay, next, eighth one. After washing, to avoid the problem of post precipitation here, to avoid problem of post precipitation, to avoid the problem of post precipitation or co-precipitation or co-precipitation or co-precipitation, it is frequently advisable. It is frequently advisable to dissolve in the precipitate in a suitable solvent and then it re-precipitate here. To here, this is to avoid the problem of post precipitation or co-precipitation. It is frequently advisable to dissolving the PPT or precipitate in a suitable solvent and then re-precipitate and then reprecipitate it. Here, the 8th point, to avoid problem of formation of post-precipitation and co-precipitation, it is frequently advisable to dissolve the precipitate in suitable solvent and then it is reprecipitate. When it is dissolved, when add the suitable solvent and then the solution is reprecipitate. This is the 8th point. Next, 9th one, the precipitate must be insoluble. Ninth one, the precipitate must be insoluble. The precipitate must be insoluble. When precipitate is soluble, it does not form any precipitate. The precipitate must be insoluble. Next, 10th point. The physical nature of the precipitate must be physical nature of precipitate, repeating, must be such that it can be readily separated from the solution. Separated from the solution. Next, 11th point. The precipitate must be converted into another. The precipitate must be converted into another form or another pure form. Another pure form of substance during heating. This is the 11th point. Here, 9th one is the precipitation must be insoluble. When you are adding the suitable solvent, the precipitation must be insoluble. And the physical nature of precipitation must be such that it cannot be readily separated from the solution. In physical nature here, it can readily separated from the solution. 11th one, the precipitate must be converted into another or pure form of the substance. Another form or a pure form of the substance during heating. During heating, they converted into the another pure form. These are the optimum conditions for precipitation or the conditions of precipitation. This is you write and ask 5 marks question. You write any of the 5 points, or you 6 marks. You write any of in 5, 6, 7. You remember 5. You write 5 points, 6 points, 7 points. This is the question. Very important question for 5 marks. I will stop class here only. In next class, I'll discuss the co-precipitation principle and advantages of co-precipitation.